Okay, a couple things. While I pull this up, I added a couple slides because I would like to talk a little bit more about periodization, a concept we'll get to here in a little bit, just so you know. So this PowerPoint presentation will look a little bit different than the one that's currently posted on eLearning. So to start, in chapter 9, I'm going to do what I did with chapter 20 and leave the slides minimized so that I can take notes on them and you can see what I'm typing as I go. So with regard to terminology for chapter 9, strength, power, and endurance is something we've already talked about in class. So quickly, just to reiterate, I knew I'd have a little bit of time in class to talk about this, so we defined these terms, but really only ever focused on strength, which is the maximal force a muscle can generate. So remember, the best indication, the best measurement we have of muscle strength is a 1 repetition maximum. It's very similar to VO2 max in the world of aerobic and cardiovascular health. And you always start with a warm-up. So remember I talked about a set of 10 repetitions to a set of 8 repetitions to a set of not 6 to 4 to 2, all increasing in weight. And then when you get to sets of 1 repetition, the weight increases by 2 to 5 pounds from set to set to set to set until you can no longer perform the repetition. So if you think about it, warm-up sets, reps from 10, 8, 6, 4, 2, and then test sets are sets of 1 with increasing weight until no longer able to lift. So that's how a 1 repetition maximum test would go. 1 RM test. You always do a couple sets of warm-ups just to get your muscles ready to go, get your heart rate increasing a little bit, just get muscles and tendons and ligaments all kind of warmed up and ready to go for the actual activity. Power we talked about was slightly different. It now includes a time component. So typically a 1 repetition maximum is a very heavy weight and can't be lifted explosively. So to test for muscle power and to generate the most amount of power in a muscle, the amount of weight that an individual is lifting is typically lower, but the lift is performed explosively as opposed to just lifting and lowering the weight, which would be a measurement of strength. So power focuses on explosiveness. And lower weights, think 50 to 65% of 1 repetition maximum. These ranges will vary a little bit, but lifted as quickly, explosively as possible, under control, and with good form. That's incredibly important. Endurance, again, can be defined in 2 ways. So we talked about 2 ways to define muscle endurance in lecture last week when we were talking about chapter 10. Endurance can be defined as the capacity to perform repeated muscle contractions, meaning that someone who can contract a muscle at a given force 20 repetitions at 100 pounds versus 30 repetitions at 100 pounds. Who would have greater muscle endurance? Answer that question for me. As well, or you can say, you can sustain a single contraction over time. So definition 1, answer me this question. Definition 2, one person can hold that 100 pounds for 30 seconds versus hold 100 pounds for 60 seconds. Who has a greater muscle endurance? Answer those questions, just as a review before we keep moving forward. A couple other things to reiterate is when we talked about muscle power 2 slides back, muscle power means in like skeletal muscle power, the ability of the muscle to generate force. Aerobic power and anaerobic power are defined a little bit differently because they are dependent upon energy systems. So think aerobic versus anaerobic glycolysis. And aerobic power is defined as the rate of energy released by oxygen-dependent metabolic pathways. So think aerobic capacity, VO2 max is really important, right? So this is the best, remember, the best indication we have or the best measurement we have of aerobic fitness. So aerobic power is defined, remember, a maximal aerobic effort equals the most amount of work done at the highest intensity that can be sustained for 2 to 3 minutes. I have 1.5 to 3 minutes here because it's a little bit variable. Typically by 1.5 to 2 minutes, those individuals at a particular intensity have met steady state. Remember, we talked about steady state several times. So between 2 to 3 minutes is when we take steady state measurements. So if it's a maximal aerobic effort, it can be sustained for 1.5 to 3 minutes. If it can't be sustained for at least 1.5 minutes, then it's anaerobic. And if you can sustain it for longer than 3 minutes, then you're submaximal, not maximal. So if not sustainable for 1.5 to 3 minutes, then you've not attained aerobic dominance, I'm going to call it, and are relying on anaerobic pathways to supply ATP. As well, if you can sustain it for, longer than 3 minutes, then it's a submaximal effort. Make sense? I just hit save, so it's going to give me a weird pop-up because I have this weird thing where I constantly save things. It's just a natural reaction, so give me some time for this to catch up. All right. Anaerobic power then is oxygen independent. So it's the rate of energy release. How fast can ATP be produced by oxygen independent pathways, which are your anaerobic glycolysis. So they think that the glycolysis that happens in cytoplasm. Remember, there's 2 to 3 ATP. I'll do this in the notes. Anaerobic power depends on the capacity of anaerobic glycolysis to produce ATP. And remember, you produce 2 to 3 ATP per glucose molecule, depending on its source. So remember, you get 2 ATP from blood glucose, because it has to be converted to glucose 6-phosphate first, and 3 ATP from a glucose molecule that comes from glycogen. Because you don't have to convert it to glucose 6-phosphate, it comes off of glycogen as a glucose 6-phosphate molecule. So you don't have to expend that extra ATP that you would by using blood glucose. So depending on that capacity, and that capacity improves with exercise training. We talked about it. The best measurement we have of anaerobic power is the Wingate anaerobic test. So that's something I showed you, the guy on the bike once upon a time who pedals for 30 seconds. It's a 30-second test. And across that 30 seconds, the force on the flywheel doesn't change. So the individual has to pedal against that force. And it's a very high intense force. So this is the best measurement we have of anaerobic power. But just like VO2 max is the best measurement we have of aerobic power, and a 1 repetition maximum is the best measurement we have of muscle strength. Now, with regard to exercise training, a lot of times the first question that you'll get from a client is, well, I don't know what to do or how to do it or what's best for me. So what do I do? And I've had a lot of individuals ask me that over the years. And all I can say is, well, it depends. It depends on the goal of the individual. It depends on where they start. So how trained or untrained or detrained are they when they first start training? If do they want to lose weight? Do they not want to lose weight? Do they want to gain weight? Do they want to gain cardiovascular endurance? Do they want to gain strength? So you have to just ask a lot of questions at the start because programs are very individual. And individuality depends on genetics. Remember, athletes are born and not made. So we are born with a certain ability to perform either cardiovascular or strength exercise. Some individuals are just better at cardiovascular events and other individuals are just naturally better at strength events. It's based on a lot, and genetics has a lot to do with that. So think about a person who's built with broad shoulders versus somebody who's built with not broad shoulders. An individual with broad shoulders may be in a sport like rowing or volleyball or swimming. Think Michael Phelps has really broad shoulders, right? My favorite guy. So genetics has a huge influence on performance. And that's related to variable cell growth rates, metabolism, and your ability of your cardiorespiratory system and neuroendocrine regulation of it. And some people, there's a term here called high and low responders. So again, genetics plays a role in what you have the ability to perform. So individuals who are born with a higher capacity in their cardiorespiratory systems may be better at cardiovascular events, whereas some individuals tend to be more anaerobic. I think fiber types can even be different. We're born with a ratio of fast twitch to slow twitch muscle fibers, and individuals who are born with more a predominant fast twitch muscle fiber type tend to be better at the anaerobic sports. Because remember, fast twitch muscle fibers are bigger, they're more anaerobic, they're fatigable, but they generate a lot of force and they generate it fast. So those individuals tend to be better strength athletes as opposed to cardiovascular athletes. Specificity is another kind of what I was mentioning. A training program needs to be tailored to the needs and wants of that particular individual. And if that individual wants to be better at cardiovascular exercise, we won't necessarily focus as much on strength training. Remember the person I talked about who's top heavy and has big muscles up top and just forgets about leg day. His or her legs tend to be thin and smaller. If you don't actually exercise them, they won't get bigger, they won't hypertrophy. So a training program has to stress the most relevant physiological systems for a given sport. So if an individual, and that means that if the goal of a program is to gain cardiovascular health advantage, then the program designed should focus on training that energy system. Aerobic or oxidative metabolism. So the types of activity will be tailored to train that system, meaning running, cycling, swimming, etc. Because the training adaptations are extremely specific to the type of activity you're doing, how much you're doing it, and its intensity. Your body will only respond to what you ask it to do. So if you run that's important, your cardiovascular system, your cardiorespiratory systems will adapt. If you lift weights, muscle fiber type will adapt, and energy systems, so anaerobic energy systems, will adapt. So big difference. Here I hit save again. I always do that. Continue. Specificity just means depending on how you train, your body will respond. So your body responds to its demands. Specificity. Let's go on. And it will only respond to demands by overloading the system that you're working, whether it be the cardiovascular system or skeletal muscle system, the anaerobic systems. Progressive overload just means you have to increase the demand on the body to make further improvements. Remember, like I said on the last slide, your body will respond, adapt to the demands placed on it. That's it. If you demand something from your body, it'll work, it'll adapt, but you have to ask it to do that. Otherwise, there's no reason for that to happen. Remember, your body's the best C student it can be. It only does as much as it needs to get by, no more, no less. So you have to overload the muscle beyond what you would normally do in a given day, in a given 24-hour period. So think about what you do in a 24-hour period. You walk around campus, you go to class, you sit down, you work on a computer, maybe you go to work, maybe you volunteer, maybe you hang out with friends, maybe you play a sport. So those things that you do in a normal day, other than playing that sport, are just activities of daily living. You have to test your body. You have to demand more from your body for it to adapt. So progressively training, so think about doing an exercise training program for 1 month. It eventually becomes easier because you adapt. We talked about all the adaptations that occur. So at the end of that month, you then need to overload again. So overload doesn't just happen once. You have to continually overload as your body adapts, which is called progressive overload. Once the body adapts to one program, one training program, whatever it might be, you need to demand more. You're resetting the set point of normalcy. So you have to increase the demands. So you have a new normal. And as you set a new normal with one training program, then you have to overload beyond then. So if you want to continually gain, you can't just initiate a program and then stay there. So remember, it gets easier over time. Your muscles hypertrophy, protein synthesis increases, anaerobic pathways adapt, neural adaptations occur. Remember, in the first 8 to 10 weeks of exercise, and then beyond, hypertrophy starts to occur. So this new set point gets created so that as you progress in this first initial program and it becomes easier for you, then you're able to adapt even further. But the demand has to increase from there. So that's called progressive overload. It's a simple concept, but a lot of people don't understand that if they're doing one thing in a program, they're going to have to change it at some point. So you have to mix things up. You have to increase either volume or intensity, which leads us to periodization. This is a principle that we often used highly in sport-specific training, but can be used by anyone. Periodization is basically a type of exercise program. Think of it as a program prescription that changes one or more variables to keep training challenging. So remember, keeping training challenging prevents plateau, which constantly demands more from muscle. And if you're constantly demanding more from muscle, then you're constantly gaining. So this periodization, this is where I added a couple of slides. This slide is relatively similar to what you might be looking at if you're looking at the previous slides that were posted. The only thing I added on this particular slide was an actual definition of what volume means. So to keep training challenging and keep individuals from getting bored or overtraining, there's a lot of goals of periodization. We mess around with, we modify volume and intensity. And volume is defined as the number of repetitions in a given workout versus intensity, which is what we usually use as a percent of one repetition maximum. Remember, muscle strength is the most amount of weight most amount of force a muscle can generate. So we have 1 repetition maximum as a measurement of muscle strength. So we can work in particular percentages of 1 repetition maximums, say for like a squat or a bench press or a hang clean. So think the powerlifting or the Olympic lifts, and modify volume over time based on intensity, to specify the demands on the muscle that we want most. So you can increase volume, which typically the more repetitions you can do, the lower the intensity needs to be, because you can't lift your 1 repetition maximum more than 1 time. So if you're working at like 90% of your 1 repetition maximum, you should only be able to lift that 1 or 2 or 3 times. So if you want to focus on volume, higher repetitions, you have to decrease intensity. But if you want to increase intensity, then you have to decrease volume. So they're inversely related. And periodization, the goals or what we get accomplished, the reasons it happens, goals, let's call it functions as well. My little dog just opened the door. Hang on. Knows what to say. Good girl. Okay, I'm back. So the goals or functions of periodization are to keep training challenging, as noted here, but also prevent boredom. Think about college athletes that we have in a training room every day, or think of anybody. If you do the same thing every single day or multiple times a week, over time it just gets boring. So messing around with a periodization program can be really helpful in preventing boredom. But it also prevents overtraining, which prevents injury. So at certain points in athletic training, there are different seasons. So think like off season in a sport like soccer, or preseason, where training for your sport is really high volume. In a preseason, you may be doing 1, 2, or even 3 practices a day. So during that preseason time period, it could be just a couple of weeks. In a weight room, we won't be doing that much. We may be doing something to keep muscle strong and keep muscle powerful. But if there's a really high volume of athletic performance on a field, we'll do a lot less in a gym. So but in an off season, when athletes aren't training at all for their sport, hang on guys, I gotta hit pause. I'm going to pause the share and okay, I've unmuted myself and I am going to resume share. I don't know what that means. Okay, hopefully you can still see this. I will check it before I post it. So again, the goals of this are important. Keep training challenging, prevent boredom, prevent overtraining, which prevents injury. So I have a couple of slides here to show you how periodization is broken down. The only thing I want you to ignore here, and I will insert kind of a shape here to strike this out, is the quadrennial cycle. So I'm going to just kind of get that out of there. And I'm going to go with a bright red to get rid of that, because I won't talk about a quadrennial cycle. That's multiple years. And in athletes, we typically focus on a macro cycle, and this macro cycle is roughly a period of about a year, sometimes less. But if you think about it, when we're training athletes, especially college athletes, they are training off season. And then, so say, think like over the summer when school's not in session. And then preseason may start right at the end of summer and head into the fall. And then in the fall, there may be season. And then the season happens. And after that, you run into the postseason, which is your competition. Postseason equals competition. So think playoffs. Let me go back and kind of write some of these. Off season equals no sport. High volume training. Preseason equals high volume sport. Low volume weight training. Postseason competition and playoffs, which is, and that's where we will focus on low volume or maintenance training. And then we head back into the off season. So there's really, season. I forgot season in there. That's important, which equals high volume of competition, low volume, high intensity training. And then that would be high volume. And we'll talk about why low intensity training. So all of that's important to understand to start. So this macro cycle is made up of an entire year for an athlete, and it includes the off season, the preseason, season, and competition or postseason. So in that macro cycle, all of these are included. Then we break the macro cycle into mesocycles. Think phases, and they are typically 3 to 4 weeks, but that depends on, includes mesocycles. So we'll say mesocycle 1 is off season. And then I'm going to go mesocycle 2. So off, and these can vary pretty greatly. Mesocycle 2 may only be a couple of weeks. Mesocycle 3 may be a couple of months. So this can vary pretty greatly. And then postseason is usually a couple of weeks as well. And that would be mesocycle 4. Let's go, 2 to 4 week postseason. Then season may be, depending on the sport, 2 to 4 months. Preseason is usually a couple of weeks. So let's say 2 to 4 weeks. So if you look at it, I'm kind of looking in mesocycle phases. Off season could be months and months and months. This could be let's go 2+ months. So just for some specific examples, and just always saving. In a microcycle, that's only about a week. So between microcycles, we will, here we go. Between microcycles, let me go down here. Microcycles are within each mesocycle. Comprised of microcycles of 1 to 2 weeks, separated by weeks, 1 week of active, mesocycles. 1 week, 1-ish of active recovery. We'll talk about what active recovery is here shortly. So in those microcycle 1, you focus on a particular volume and intensity of specific workouts. Then increase volume or intensity each microcycle. So you're progressively overload muscle. Then, between mesocycles, there's a week of active recovery, which allows us to drop volume and intensity and allow for recovery, which means we're preventing injury, but maintain gains, which is really, really, really important. So we kind of broke down periodization. So basically what we're doing is illustrated. So from all of those kind of definitions, here's how long a macrocycle, mesocycle, microcycle is. Here's, microcycles make up a mesocycle, and mesocycles make up macrocycles. In the next slide, it kind of gives you some ideas of what we would focus on in particular. So this is, for an example up top here, preseason phase breakdown. So this is one of our mesocycles broken down into microcycles. So let's go here and insert, actually, let's just copy and paste a text box. So we've got, this would be, I don't need those words there anymore. This would be a mesocycle. I'm gonna increase that. Preseason. And then I'm gonna copy and paste that into microcycle. This is a microcycle. And then this is a microcycle. Different focuses of microcycles. And again, microcycles and macrocycles can kind of change with regard to their, let's just get rid of this guy. So this is an example of a 1 week microcycle where you use an introduction. One of the first things that we do when athletes are stepping foot on campus, so think college athletes, is use at least 1 week, typically 2, to train the athletes. So intro equals train proper form. So we start teaching them how to do a squat perfectly with good form. We teach them how to do a bench press, a hang clean, a jerk, a snatch. We teach them how to do all those things with proper form, with very low weight. Train proper form, very low weight. Just to introduce athletes to new lifts and how to perform them safely, properly. But also learn how to spot. Spotters observe to maintain safety. Okay. So introduction is always important. Those are our teaching moments. That's where we teach, train proper form. If we're trying to gain endurance, so you start to do basic exercises that focus on form and technique, but increase weight just a little bit to start to train. And training endurance, by training endurance, you can also train for muscle strength. By training for endurance, you can train strength. Because training for endurance induces hypertrophy. And a bigger muscle is a stronger muscle. Right? Okay. Then when you want growth, think hypertrophy. You want to focus on high volume and lower weight. So think 60 to 75% of 1 repetition maximum with more advanced exercises that would focus on building muscle mass. So if you want growth, hypertrophy, focus on low weight, high rep, low weight, which means intensity, high volume, which means repetition, to gain the most hypertrophy. So you'll start to work at lower percentages of 1 repetition maximum. Then so on this particular figure here, where it says transition, this is active rest, where on the previous slide I termed it active recovery. Same thing. Athletes should be focusing on higher volume, depending on where they're at in their season. If they're in preseason or off season, this may be high or low volume. Usually, let's go like this: low volume, low weight. Just because we don't want them to do a whole lot of activity, but we still want them to do something so that they don't lose any of the gains that they have attained. So low weight, low volume, but that active recovery allows them to maintain all the gains that they have achieved in the first mesocycle or whatever in the previous microcycles. If you want to focus on strength, you lower the volume and increase the weight. Remember, a definition of muscle strength is the most amount of force a muscle can generate or produce. So if you're focusing on gaining muscle strength, you focus on low volume but high weight. So think 75 to 90% or even higher of 1 repetition maximum. Then remember, if you want to focus on power in a microcycle or phases of a mesocycle, you have to lower weight to focus on explosiveness. You can't lift a heavy weight. Shouldn't be able to. You can't lift a heavy weight fast. So to focus on power, you lower weight and increase speed, explosiveness, which means you'll focus on a lower percentage of your 1 repetition maximum, not necessarily a high volume, so not tons of repetitions, actually lower volume. If you want to focus on explosiveness, you want the most out of the muscle every time. The best effort from the muscle each rep. So low reps, volume, moderate to low weight, intensity, focused on exploding. So this would be like an Olympic lift, a power clean, or a hang clean, or a jerk, or a snatch. If you don't know what those are, Google them. There are some pretty good videos of how to do a power clean, a hang clean, a jerk, or a snatch. But they are considered powerlifting and they are considered Olympic lifting. So if we are going to focus on power output in a training program, we're going to end up focusing on exercises that would allow us to focus our muscle activity around power. So think those particular lifts. And then after that focus, you always, after that mesocycle and in between mesocycles, you want to focus on an active rest. So down here in this second figure, this second table, is just a kind of conceptualized, periodized training program. So there's a transition phase, that's active recovery, preparatory phase, and then competition. So this would be one macro cycle. And then mesocycles are broken down into microcycles and across an entire year. So it kind of just gives you an idea of how you would lay it out, and how you would lay out each workout depends on the needs of the athlete. Are we focusing on growth? Are we focusing on strength? Are we focusing on power? And remember, growth and endurance kind of go together along, and can, as you're gaining growth, hypertrophy, and endurance, you can also gain muscle strength. So very rarely do we actually focus a program on muscle strength, because if we're focused on growth and endurance, hypertrophy and endurance, then by default, we're gaining strength. And typically what happens is at the end of each mesocycle, we retest 1 repetition maximum to determine gains. And if there haven't been gains, or you're losing your 1 repetition maximum, or if you're only maintaining, we want you to gain, then we know if losing strength or maintaining strength when we want to gain, then we know we need to modify our next mesocycle to improve 1 RM, right? So hopefully all that makes sense. If you have any questions about that, of course, email me anytime. So again, a couple of things to finish this up. We've talked about concentric versus eccentric muscle contractions and isometric. Isometric muscle contractions, where the muscle doesn't change length, doesn't really apply much to athletics and sports. So we typically focus on isotonic muscle contractions, so think concentric and eccentric, whereas eccentric muscle contractions tend to benefit muscle strength more. We talked about intramuscular damage and how eccentric muscle contractions tend to lead to a greater amount of intramuscular damage, because in an eccentric contraction, using eccentric contractions, a muscle can generate more force, which means more intramuscular damage occurs and hypertrophy, the hypertrophic stimulus, is greater. The exercise order is also really important. So in any single workout, exercise order should look like this. Should always start with larger muscle groups. So think quads, hamstrings, lower body, or chest, back muscles, upper body. So the bigger muscles, which also tend to involve multiple joints. So think squat, bench press, as opposed to exercises like bicep curl. That only involve one joint. So think about it. If you're using multiple joints, you're using a lot more muscle. And if you're using a lot more muscle and you want to get the most out of that muscle before fatiguing it, prevent fatigue in bigger muscles, to prevent fatigue in muscles you need for the bigger exercises. So you need muscles like your biceps and your triceps to perform a bench press. So if you exercise just the bicep and the tricep first, and in like a bicep curl or a tricep extension, and then you go do a bench press, well, you may have already fatigued the bicep or the tricep first. You use triceps predominantly in a bench press, and then you try to go do the bench press where the tricep muscle is an accessory muscle to help lift the weight in the bench press. You won't get as much out of the bench press. So the bigger muscles, so think your chest muscles. So for example, if you focus on tricep extensions first, then bench press, the tricep is fatigued when performing the bench press, and you'll not be able to lift as much in the bench press. So to get the most out of the bigger exercises, you need to do them first when the muscles are fresh and ready to go. So you always do large muscle groups first, and then multi-joint, which is what I was just talking about before single joint, and always high intensity first. So Olympic lifts like cleans, jerks, snatches, or plyometrics, which we're about to talk about. So I'll just leave it at that for now. Let's go like that. And then rest periods depend on your experience and also the needs of your training program. If you only have 30 minutes, then your rest periods are going to be short. And you would do something like the one group talked about in their presentation last week. You would do supersets, where you could do a push and a pull, or an upper body and a lower body to minimize rest period overall, but still give a rest period to certain muscles. So as you're exercising the upper body muscles, you're resting the lower body muscles, and vice versa. And advanced lifters can take 30 seconds to 2 minutes between sets and be perfectly recovered. During recovery, think you are replenishing like your ATP PCR stores and preparing for the next lift and clearing lactic acid and things like that. So rest periods are important, but they can be minimized with training. And then when you're thinking about free weights versus machines, free weights give you a constant resistance around a particular joint angle, and that taxes the muscles in an entire range of motion. So free weights are great and used to tax a muscle, to test a muscle in its entire range of motion. So ROM, and recruits supporting muscles. So you get the most out of the muscle. And you also recruit supporting and stabilizing muscles that may not be recruited when using machines. So in using free weights, you tend to gain faster because you're engaging more muscle with every lift. But there is some level of instability in stable because a machine helps you stay stable. But so free weights are not recommended for new lifters, new exercisers, we're going to call it that, new lifters. When you are unsure of how to perform a lift, or if you don't have someone to teach you, then you can use machines. Machines are safer, they're easier, they're more stable, they're better for new individuals to weightlifting, but they limit your recruitment of the targeted muscle. So the machines do some of the work for you as opposed to free weights. So there's a benefit and a cost to using either. When you use free weights, you engage more muscle, you can gain faster and gain more. When you use machines, they're safer, but they limit the target to a muscle group, and they limit the muscle group's ability to use its range of motion, its full range of motion. So there's pluses and minuses to both, and that's whatever you decide to use just depends on your goals or the goal of your client, depending on who is in question here. Plyometrics are something that I mentioned earlier. This is basically an exercise that uses the stretch shortening cycle of a muscle. So remember the time I asked you to jump without bending your knees, and then jump with bending your knees a little bit, and then jump by bending your knees a lot. If you weren't there that day, then I want you to try this exercise. Stop the video, and I want you to perform 3 jumps. 1 jump without bending your knee at all, and then 1 jump by bending your knee just a little bit, and then another jump by bending your knee a lot. So you should jump the highest when you bend your knee a lot, to a certain extent. So basically what happens is we have a stretch reflex, where when you stretch a muscle, you get a sensory signal sent to your brain that helps that muscle contract and recruit motor units. So, and what happens is between the ECC is eccentric phase. Think the lengthening phase. You build up and store energy. By stretching the muscle. Give me that, there we go. Then in transition from eccentric to concentric, the stored energy, the energy is stored. But the longer you stay in the transition phase, the more energy you lose. So the faster you move from eccentric to concentric phases, the more energy stored you are able to use. So eccentric to concentric, the concentric, remember, is just shortening, the shortening phase. So the energy that's stored during eccentric phase is released during the concentric phase. So the transition between the two, basically where you stop and you move from eccentric to concentric contraction, is when energy is stored. So if you stay there longer, you'll lose some of that energy. So do two things for me. Do two more jumps, 2 jumps. Jump 1 means bend your knees and jump up as fast as you can and move from the down to up to jump as quickly as possible. Then you may hear my dogs bark. I have a person here in my home that is coming to visit. So please bear with me if I have to stop for a minute and let them bark. Then jump 2 is bend your knee and hold at the bottom for a few seconds. Then jump. Okay, I'm gonna have to stop. And I will finish the video later. I will do the second half of the presentation for you guys here in a bit. I have to, there they are. I'm about to end the meeting. So I will do this in 1A, 1B. Zoe.
You good?
Yeah.
What do you